So the warm-up problem was a problem where two students had kind of kept track of their food expenses and then reported it out, and your job was to think about who was spending less, and then how would you kind of figure out who would spend less over the course of the whole year. So let me share my screen here. Okay. This is what I want right here. So I think the two pieces of information from the announcement, let's see. Oh, just some quick other housekeeping things. Logbook 1 was due on Friday. If you haven't sent it in, no big deal. Just send me an email. Remember, you're trying to write 200 to 300 words. There's some word counting stuff on the internet you can use. If you're not sure how much that is, you could put it in a Word document, and it would count it for you. And then you've already got the prompt for Logbook 2 up. I did post advice from previous students on how to succeed. That's logbooks from the spring semester, second 8 weeks. Those are people who did something very similar to what you're doing in terms of virtual class in the middle of a pandemic. So I think that should be very relevant to your experiences. Okay, so you got one student who spent $345 over 50 days. And then you have another student who spent $45 in a week. So I try to throw a little curveball at you there by giving you different units of time, but of course I could just replace 1 week with 7 days. And I mean, that's an assumption, I guess, because we could be talking about a work week or a regular week, but I would assume that meant 7 days. And then we can use that to set up ratios to see, student 1 or student A versus student B. It's hard to compare them directly because, they did it for a different number of days. But if we make a ratio of dollars to days, then that gives us how many dollars per day they're spending. So if you look at student A, it ends up being $690, and if you look at student B, it ends up being $643, right? And so from who's doing better perspective, we would say student B is doing better because they're spending less on food every week. If your goal was to spend less, which from my perspective, food is a challenging thing because there's basically at least three different components that kind of come into play when you're thinking about how do I need to eat? How much does it cost? How much time does it take me to prepare it and consume it? And then, because you're busy people, and then what about the nutritional value that comes with that, right? Because if I have something that doesn't cost very much and doesn't take me very much time, aka fast food, but fast food not necessarily great nutrition, that can kind of be hard on your body's engine as you go along if that's all you ever consume. So it's a very interesting question that has some math components in it, actually, all three of those: time, money, and nutrition, which you could measure in terms of calories or whatever. So the question about the year then is essentially a proportional question. And we didn't get to this on Wednesday in talking about proportions. I feel pretty confident that you've all seen proportional problems before, but I don't know whether you remember how to solve them. The typical way of solving a proportion is that so say you have x over 5, and you're trying to figure out if that's what x would be if this was 45 out of 50. So these are both fractions. So mathematically, what I would say, if you don't remember how to solve proportions, you can rewrite this and continue on as if this were an algebraic equation, multiply both sides, and I think Becky talks about it like that. But from my perspective, it's just really a two-step process. You multiply diagonally and divide by the other number. And when I say multiply diagonally, I mean multiply the two numbers that are actually numbers. So I'm not talking about the x and the 50 because you don't know what x is, but you can do 5 times 45 and then you can divide it by 50. Go ahead and do that, and let's hear back about what your answer is. So what would x need to be to make this proportional?
4.5.
Yeah, good. Okay. And that turned out nice. There wasn't any rounding issues, but it doesn't matter whether it's nice or whether it's disgusting. This is a process, multiply diagonally and divide by the other number, which can be used in any configuration, right? So maybe my x is down here. That doesn't matter. I can still solve this problem, right? By multiplying diagonally and then dividing by the other number. Go ahead and do that one. I think this answer is not going to be as nice. So let's just say we'll round to one decimal place.
It'd be 115.
Well, that's the first part, because 10 times 15 is 150, but then we need to finish by doing what?
We're going to divide by 13.
Good. So we take 150 divided by 13. If we're rounding to one decimal place, we would say x is 11.6.
5.
Yeah, I would go with 5, right? Because the next number after the 5 is a 3, so we'll round down. Now, this is an approximate answer, right? And what I mean by that is that if you put 11.5 here, and you think about what this is actually saying, a proportion is just a comparison of two ratios, right? So if I look at 10 divided by 11.5, that's that number. And if I look at 13 divided by 15, that's that number. Now those are pretty close, right? But they're not exactly the same. So that's what I mean by 11.5 is approximately the right answer. What's exactly the right answer is this crazy number here, which is 150 divided by 13. So that's how you solve proportionalities, is you set yourself up with a little, this ratio is equal to this ratio. There should be one missing piece of information, and then you go from there in terms of solving it. So in terms of this problem, as we think about going back to the board work and think about, how much are they spending per year? How much is student A spending per year? There's actually multiple ways to do it, and we don't have to use this proportional setup, given that we've already done this 690 calculation. But we could do it using the 345 and the 50, and I'll just use the setup I had over here, show you what that would look like. So it would be something like 345 over 50 equals what over 365, right? So In this problem, in this setup, I'm putting my dollars on top and I'm putting my days on the bottom. And I converted 1 year into 365 days. And the reason I did that is because since this number on the bottom was days, I needed to be talking in terms of days over here. So you could solve the problem this way. Go ahead and multiply diagonally, divide by the other number, see what you get. And then I wonder if anybody can come up with the second way of solving it that doesn't involve setting up a proportion. So we're answering this question. How much is student A spending in a year?
I got $2,518.50.
Okay. So if we take 345 and we multiply by 365, we get this enormous number. And then if we take that number and we divide it by 50, we do indeed end up with 2,518.50. Okay. Does anybody find a second way to do the problem that doesn't involve setting up a proportion?
You could just multiply it by 365.
Multiply what by 365?
The $6.90.
Right. And that's the beauty of having that ratio, right? If it's $6.90 per day, then if I just multiply by 365 days, that gives me how much I would spend in a year. And we can prove it to ourselves and see that we get the exact same number. Okay. Okay, that's a reminder that math is not a one-way program. It's not like there's just one way to do it and you got to do it this one way or you're going to get it wrong. Another example of that is that actually there's different ways I can write the same proportion and it still gives me the same answer. For instance, I could put my 345 over question mark and then my 50 over 365. Notice that when I multiply diagonally and divide by the other number, it's still the same operation. I'm still doing 345 times 365 and dividing by 50. So in terms of solving a proportional problem, there's really two parts. And this connects back to the cheeseburger of quantitative reasoning, which it's always good to kind of go back and look at that and think about how that applies, right? The interpret is you're reading a problem and you're saying, how do I get the numbers in the right place? The do math is literally just the multiply and divide, and recontextualize is at the very least making sure you get units on the number so it's clear that you know what you're talking about. So let me give you an example here. I'm not going to start with this map question because, for God's sakes, nobody's using maps nowadays. Let's use the house assessment. Number 3 here, a house assessed at $73,000 has a property tax of $1,600. How much property tax would the owner of a house expect to pay if his house was assessed at $87,500? First of all, should we expect to pay more tax or less tax? Just
More.
based on the words.
More.
Yeah, more, because the house is more valuable, so we should expect to pay more tax on it, right? That's the way it works. So go ahead and set up a proportion. See if you can set up a proportion that's going to have those three numbers in it, the 73,000, the 1,600, and the 87.5. And then once you've set it up, multiply, divides, come up with the number, and we'll kind of check back in here in a minute, make sure everybody feels good about that process.
I did 73,000 over 1,600.
Okay.
And then I multiplied 1,600 by 87,500.
So then on this side, you would have this over this, right? I like using the question mark just to de-emphasize the algebraic nature of this. There's really only one part of this course where you are actually going to be writing equations and then potentially using them to solve things. But I really try to de-emphasize the algebraic part because that's, as I said on day one of the design aspects of the course is this is not about your algebraic abilities. So perfect, right? On the top, you've got the value, and on the bottom, you've got the tax. So I would say that's kind of the key to writing a good proportion. Writing a good proportion you are consistent across the top and bottom and left and right, right?
See-
So, yeah, go ahead.
I was gonna say what helps me remember this kind of question. I usually do the is of is times x over 100. That's how I usually.
Yeah, it's in is over of generally people apply that more to percentages.
Percentage, but
But if
I
it
use
helps
that.
you, if it
Yeah.
helps you set it up, that's good, man. And feel free. That brings up a great point about, because none of you are coming to this math class like this is your first math class. So anytime you know something from before and you feel good about it and it works, boom, use it. Okay. Cool. So the answer there, and there is a little minor detail about rounding because it did have specific rounding instructions. Like I said, rounding is a part of the course. It just keeps coming up over and over again. So what were the rounding instructions? I don't know if you've got your book open. This is on page 32, I think.
It's the nearest dollar, right?
Right. And so that would mean the answer should be rounded to
1918. I mean, $1,918.
Yep. Now, if you're taking a quiz, see, this is one of the differences between in class versus on a computer. When you're taking it on the computer may be programmed to respond very specifically to your rounding, so it might not consider this correct. I mean, not this. You should at least round, this is money, you should at least round it to this, but it may not consider that correct, right? And that you've still done all the math correctly. You just missed a little detail about the rounding. So I do try to go back on the big assessments and give partial credit for little mistakes like that. But, you know, again, from my perspective, the attention to detail is just one of the things that you're developing as a student. Okay, that page is a great page to practice proportions on. There's about 6 or 7 problems there.